So this question is in three parts. However, the parts A and parts B are there to help guide you to complete part C. This is essentially a two routes question where we're trying to demonstrate to get from a position, let's say position O we're going to choose, to position D. Okay, so we want the vector O to D in two different directions. And essentially we're trying to demonstrate that M to D is half of M to N, and SD is half of S to T, and then that will demonstrate that the lines bisect one another. Okay, let's start off with part A. So we're looking to try and get the vector M to N, which is M to B plus B to C plus C to N. Now, I've already populated the diagram with the ratios of positions M along O to B, and that can just be very helpful to then just focus on the diagram itself and pick out information that I need. So M to B I can see is going to be 7/9 of O to B, which is 7/9 of B. B to C, well, that's parallel to O to A, so that's A. And C to N, well, that's going to be 2/9 of negative, so we're going in the opposite direction of O to B, from C to A. So that's going to be negative B there. So I'll just tidy those up. So I've got A plus 5/9 and B. Okay, so we'll just put that to one side for a moment. And then focus on part B, expressing S to T. So part B, I want the vector S to T. So I'm going to go clockwise again. So S to C plus C to A plus A to T. So S to C is going to be 7/9 of A minus B minus 2/9 of A. Collecting those like terms together there, so I've got 5/9 of A minus B. Again, I'm just going to collect these together now and group them. Put them to one side. Okay, so nice and straightforward there for parts A and B. Now we need to demonstrate that the lines bisect one another. So it's the two routes method, and I'm going to be comparing coefficients. And what I'm going to do is I'm going to start from a common point, O, and I'm going to be looking to try and get to O to D, so the vector O to D in two different routes. So the first route I'll take is going to be O to M plus M to D. So O to M is 2/9 of B, and M to D, well, that's going to be some multiple of M to N. So we can see why we needed to work out what M to N was. So we can now substitute that into this result. So bringing it in from here, I'll expand that out and I'm going to collect like terms. So I'll do that in two steps. So I've got 2/9 plus 5/9 KB. Okay, so that's the vector O to D. So I'm kind of running out of space here. So group together and just put to one side for the moment. I'll use a different color, so I'm going to now find the vector O to D again, but this time from a different direction. So this time I'm going to go O to B, B to S, and then S to D. So S to D is some multiple of S to T. So we're trying to show that it's equal to a half. But for now, let's just use another letter as a multiplier, as a scalar, sorry. So we're going to use T. And that's going to be some multiple of S to T. So S to T is what we generated down here. So if I just substitute that into this and expand that out, so what have I got? I've got 2 over 9 plus 5 over 9t a plus 1 minus t b. Okay. So I'm just going to check that through. I'm happy with that. Yep. Okay, I'm happy with that. So let's just reduce this down now, collecting the like terms. Like so, just put that to one side. Now, I've got the vector O to D from two different directions. Now I'm going to set them to be equal to each other. Okay, so I'm going to take this vector here. So I've got Ka plus 2 over 9 plus 5 over 9 Kb, and that's going to be equal to this vector here. So we've got 2 over 9 and now I'm going to compare coefficients. So on this side here I've got K, and on this side here I've got this expression. So K must be equal to 2 over 9 plus 5 over 9 t, and on here I've got this expression for B and this expression for B. So 2 over 9 plus 5 over 9k is equal to 1 minus t b. Don't need that. I'm just interested in the coefficients. I've got two equations there. Now I need to try and solve them simultaneously. So I need to make some space. Okay, just put that to one side. So how am I going to do that? Well, I think I'm going to focus in on this equation first. Maybe get rid of the 9s as a fraction. So I'm going to multiply both sides by 9. Okay, so I'll get 9k is equal to 2 plus 5t, and probably do the same thing with the other side. Now what I'm going to do with this one, I'm just going to rearrange that to make t. So this equation here, so 2 over 9 plus 5 over 9 k No, I don't like doing that either. Let me just see what I've done in my notes. Yep, okay, I have done that. So I've taken the t to one side there, so t is going to be equal to 1 minus 2 over 9 minus 5 over 9k, which is 7 over 9 minus 5 over 9k. So I've got the two equations now, t here and this. So I'm now going to substitute the t into this equation here. So I've got 9k is equal to 2 plus 5 lots of 7 over 9 minus 5 over 9k. Now I'm going to times by 9 again on both sides. So I've got 81k is equal to 18 plus, so the 9's will cancel out here. So all I've got now is 35 minus 25k. Scroll the board down. Add 25k to both sides, so I've got 106k, and that's equal to 53. K is 53 divided by 106, which comes to a half. Brilliant, that's looking good. Put that to one side up there. I'll now substitute the value of k into one of the other equations. So I'll substitute it into this equation here. So I've got 9 times a half equals 2 plus 5t. So 9 over 2 . So I'm just going to times that by 2. So 9 is equal to 4 plus 10t. So 10t must be equal to 5. And t is equal to 5 over 10, which is a half. So after all that effort, let's just focus on what we've got. So we know that t is a half, and we've established that k is equal to a half, and we were trying to demonstrate these scenarios here. Let's just look back to our work where we said that k is the scalar. So the vector m to b, m to d is some multiple of m to n. Well, k is a half, so it's half of m to n. Yes, this is what we were trying to show. And then in the second scenario here, we said the vector s to d is some multiple of s to t, and that is also equal to a half. So that demonstrates that the lines m and n and st bisect one each other.